In this video, we will find the solution of this differential equation. So let's start. First of all, let us assume that the solution of this equation is, let the solution of this equation y is a e to the power mx. Now let's find dy dx. Dy dx will be, a is constant, so e to the power mx, derivative of e to the power mx is m e to the power mx. So this is nothing but a to the power mx, so it is nothing but my, right? So now let's find d²y dx2. So in the next step we can write a m, and e to the power mx is m e to the power mx, so it will be m square e to the power mx. Now again we can write it as m square y. Now let's put it in this equation, d2y dx2 plus omega square y. So if we put this, we will get d2y dx2. So d2y dx2 is m square y plus d omega square y. So it is omega square y equals 0. In the next step we can take common m square plus omega square, so we can take common y, so it is 0. Now y cannot be 0, so our m square plus omega square must be 0. So in the next step we can write m square as negative of omega square, and then we can write m is equals plus minus I omega. So the solutions are y1 equals to a1 e to the power I omega x, and y2 is equals to a2 e to the power minus I omega x, right? Because we have assumed that y equals to a to the power mx, so our aim is our plus minus I omega. So y1 will be a1 e to the power I omega x, and y2 equals to a2 e to the power I omega x. So general solution will be y is equals y1 plus y2, and our y1 is a1 e to the power I omega x plus y2 is a2 e to the power minus I omega x, right? Now from Euler's theorem we know that e to the power I theta can be written as cos theta plus I sin theta. So let's do this. A1 cos e to the power I omega x is cos omega x plus I sin omega x plus a2 e to the power minus I omega x cos omega x minus I sin omega x. In the next step, let's take common the cos part, so it will be a1 plus a2 cos omega x plus now sin omega x, so it will be I a1 minus a2 sin omega x. Now let's write a1 plus a2 as capital A cos omega x, and this as b, so it is b sin omega x. So our general solution is y is equals to a cos omega x plus b sin omega x. So this is the solution for d2y dx2 plus omega square y equals 0.